Well, if we are remote, this is a section that's pretty difficult to teach if we're using our calculator, but I didn't want to just skip this because there's a lot of features in your calculator like stored tables, and you can learn a lot just from being able to do this, because if you don't have a calculator, you just might have to know to do this in your head. 5 squared minus 2 times 5 plus 7 by inputting that into your calculator. Or what you can do is hit this store key, and so you hit the number you want and then store in for x. The x key is up here. So 5 store x, hit enter, and then you can just plug in the function the way it looks with x minus 2x plus 7. Oops, 2x plus 7, and you get the right answer. Instead of having to struggle through, 5 squared is 25, minus 10 is 15, plus 7 is 22, you quickly get the answer. So again, you can do that using, g of negative 10. You can use that feature and plug in negative 10 in for x, and it saves you from struggling through this. But just for clarification, this would be negative 20 plus 6 would be negative 14. Negative 30 minus 5 would be negative 35. And both those are divisible by 7, so you would get 2/5 for your right answer. Or you can use the store feature. Just make sure you hit the negative button, store in for x, hit enter, and then a trick to making a fraction is alpha x, and it was 2x plus 6, if my memory is correct, over 3x minus 5. And as I hit enter, it reduces down to 2/5, the correct answer. So your calculator can do quite a bit. It can even do absolute value. If I ask you to do h of 2, where maybe you struggle to do 7 times 2 minus 20 in your head, plus 2 squared, replacing 2 in for x. But that would be 14 minus 20 is negative 6, but the absolute value would change it back to positive 6. 2 squared is 4, so the correct answer should be 10. But again, you can use the store feature. And if you don't know where absolute value is in a problem, you can always find things in your catalog. If you hit alpha 0, whoops, not alpha, second 0 to pull up the catalog, and it's the very first option. And then plug in 7x minus 20, and then hit the arrow over to get out of that, plus x squared, and you get the correct answer. So definitely useful, especially if you've struggled for a little bit. So we also have this, I hope it helps you understand how you can evaluate f of 5 and see what happens. So if I asked you to evaluate f of 5, you would substitute 5 in for x. So let's do that. 5 store x, and then we have this square root of 6 minus 2x, and your calculator says that you get a non-real answer. So what does that mean is we would get 6 minus 10, which is negative 4, and we cannot square root negatives. And so what your calculator is trying to say is that we have a non-real answer, so there's no way of reducing this. And we'll actually get a way of doing this with a non-real answer, and we'll touch upon that when we get to that section. As we get to exercise 3, we can also evaluate problems a little bit differently. And the trinomial, what they're trying to ask you to do is multiply that out. I'm confident you've learned this before. you may have used the phrase FOIL when you learned this before, where you do 3x times x is 3x squared, and then you do the outside term next. 3x times 5 is 15x, and then the inside term. But again, it is just the distributive property over and over again, and it should be a review. If it's not, just make sure you ask questions in class. Because you can combine like terms, that's what makes it a trinomial, is you have 3 terms when you combine it all together. So what they want you to do in part B is to evaluate g of negative 2 using the original problem, and to also evaluate with this trinomial. So we're going to plug in negative 2 here, here, and then down here with those values. So let's do this without a calculator. If we did the top factored form, 3 times negative 2 is negative 6 plus 2 is negative 4. And negative 2 plus 5 is positive 3. Don't mess up like I did. And you would get negative 12 when you multiply that out. But if I plugged it in down here, negative 2 when you square it would be 4. And then 17 times negative 2 would give me negative 34 plus 10. So we're looking at 12 minus 34 plus 10. And you get an answer of negative 12. You can double check with the calculator. And what you notice, and I'm going to use the math term here, is that these two things are equivalent. And why is that the case? Is if this really is equal to this, you can plug in anything you want for x. As long as you plug in the same x value up here as down here, you'll get the same answer, which is what makes expressions equivalent. And you can put that in your own words on that one. I think they want you to use the store command as well. And just to save some time, if I've done enough of these store features, at least I think I've done enough of these store features, where this would make sense. Negative 25 squared is positive 25 times 3 is 75. 17 times negative 5 is negative 60. No. 7 times 5 is 35. That if you add to the 50 would be 85. There we go. So it's to your benefit to use a calculator, but you get a 0. And why does the value of this trinomial turn out to be the specific value? Well, let's think about it. If we went back to the factored form, and I'm going to point out specifically, plug in negative 5 right here, I don't care what this other value is. Because if I plug in negative 5 right here, I'll just write anything times negative 5 plus 5. Well, that's got to be 0, must equal 0. 0 times anything is 0. So that factored form is what would help us figure that out, and this is good work to help explain that fact. And then we can also use tables in our problem, especially when we get to very, very difficult problems. And we're going to use a table feature of a graphing calculator to find that 0. And by the way, we call things zeros when the result is equal to 0. So what I'm going to do is go to y equals and type this in. I'll probably forget, so I'll go back and forth. And I want to use the table feature to see when I get it equal to 0, when the y value will equal 0. Because the x value equaling 0 is not very special. If you did x equals 0, you would just get negative 32 over here. And you may recall, because we've talked about this already, zeros are also a fancy name for x-intercepts. There we go. So let's go to the calculator. Whoops. Y equals, well, I guess I have to quit out of that. X cubed. Messing up already. X cubed. And then you have to hit the arrow over to get out of that. And please bring questions to class if you are forgetting how to type in, or play around with the calculator and see if you can figure that out. Minus 32. And I'm going to hit second graph, because that'll bring up a table for me. And if you're really far off from between 0 and 10, you can always hit second window to go to your table setting and go back to 0. If anybody's playing a trick with your calculator, you can go back. And the only thing we care about is when we get a y value to equal 0. And when y equals 0, we got x equals 4. And I know the directions say to show the table. That would take a lot of work. So just a few points would be okay. And, you know, finding all the values would be also okay. Okay, so we can also use tables to establish a proof of some sort that things are equivalent. So what we could do on exercise 5 is we could actually multiply this out and simplify. So as I mentioned before, we have FOILed earlier. That would be x squared plus 8x. But then you also have to distribute that 5 into the problem, so 5x plus 40. And then you also have to distribute over here, but be careful that it's a minus in there. And that's why the problem says carefully. You have x squared to be minus 2x plus 3x, and then minus 6 as you multiply. But make sure that not only do you combine like terms, but sometimes what I'll do is I'll distribute a negative into the problem. Because normally this would be a plus 3x, but when you distribute that minus into it, it becomes a minus x and plus 6. So feel free to bring questions to me if that's confusing. And what I like about this problem is the x squareds cancel. Well, 13x minus 1x would be 12x, and 40 plus 6 would be 46. So what I want to point out is that you can use the table feature of a calculator and show that your answer is correct. So the original problem, just type that in carefully into the calculator. And then the y2 equation, we're going to just write out what we think it is. And hopefully I did it right, otherwise this is a waste of time. Yeah, so back to y equals, clear that out. X plus 5, x plus 8, minus x plus 3 minus 2, and then my other answer of 12x plus 46. And when I go to my table, if these two things are really equivalent, then it shouldn't matter if you use the first equation that was in blue or the red equation that we simplified to. You'll get the same y values no matter what. And if you look at all of them, they're all the same. So at any point you can hit pause in the video and type those in, and if they are identical, then the original expressions, y1 and y2, are what we call equivalent, which is very important stuff. So again, you need to type in 46, 58, 70, 82, 94, 106 into this table. And just to get this video over with, your homework might be difficult for you to do at home if you're really using all these features. But then the second part of this is something you can definitely do on your own, unless you come across something that says use a calculator. So you will have to do some work at home on this section.